Hi, folks. So we are on the last section, number 4, of talking about the Jovian planets around the Sun. Basically, we're going to be talking about the rings now. We've just gotten done talking about the structure, the moon, the atmospheres, the moons, and now we're going to be talking about the rings. And especially in regards to Saturn, it's the most spectacular thing in my mind about what's going on with the Jovian planets. And it's very interesting to play with little gravitational models about what's going on with that. And perhaps in the future I'll show you how that's done. But one of the things that we have in this picture here that could be contrasted with what Galileo had, if you recall what Galileo had for his observations of Saturn, is that it looked very similar to this, if you will, but it looked more like a coffee cup with two handles on either side. It didn't look like something with rings. And in particular, it doesn't look like this. Okay, I mean, we see this and it looks just spectacular. And mind you, the reason why is we are orbiting the Sun naturally, and Saturn is orbiting the Sun too. Now, Saturn has an axis of rotation that is not aligned with its rotation about the Sun. And that is true for us too. And so because of that, depending upon where we are in Earth's orbit about the Sun and where Saturn is, we can see the rings edge on, like here, or we can see the southern end, or rather the southern end of Saturn, or we can see the northern end. It's really pretty interesting. So over here we're seeing the North Pole, and we're seeing the tops of the rings, and then when we're over here, then we're seeing the bottom and the underside of the rings. Very, very interesting in that regard. Now, all 4 Jovian planets have rings. It's really a pretty amazing thing. Until we had spacecraft that went out there, we really didn't observe them, although you can say that Uranus was a special case where we saw an eclipse of a star going behind these rings and it was blinking out. All right, so unlike the other, well, Saturn is the one with the light rings and all the other ones have dark. So, and then on top of that we have these divisions between the rings, and we'll be talking about that in a little bit too. These rings are very, very thin, 100 meters thick. And if you simulate them on the Earth, this is sort of what you would get. If you were along the equator, like in Ecuador, then it would be a thin thing that looks like this. From Washington, D.C., you would see it around the axis, and so you'd see the top end. From Polynesia, you would see it from the bottom end, and from Alaska, you could barely see it at all, because remember, the rings are close to the axis around the equator, and you would have to look through the Earth in order to see it from Alaska, right? And the structures are entirely due to the interactions of the particles within here, and also moonlets that appear as well. So we have a couple of characteristics of moons. We can have gaps, gap moons, which create gaps in the rings, and we can also have what are called shepherd moons, which sort of keep track, keep the particles of the rings aligned, or they keep them in a narrow ring, as it says. We can have resonance gaps. We saw resonances for Io, Europa, and Callisto, and so they'll change the orbit, right? And they'll consistently change the orbit. And the ring formation is a very interesting bit of science here. And so our theory for that has to include the fact that all the Jovian rings, all the Jovian planets have rings now, and we have impacts from moons creating stuff, and we'll continue on. What causes ring formation? Well, our theory for ring formation has got to include the fact that all Jovians have rings now, and that we have lots of moons that are close by and they get impacted by debris. And that debris can be expressed out or regained by that moon. The rhyolite, if I've pronounced that correctly, on the surface of the moon, right? You know, those deep footprints you saw of the Apollo astronauts on the moon. And that same material is observed on Mars. And so that material, some of it can be expressed off of the planet or off of the moon and can then float around the planet in a ring. White rings are caused by water ice. And so basically that's how we can create rings about the planet. The rings that we have around Saturn, as it says here, are very, very young. And the material, if we add it all up together, as it says here, would represent a satellite that's about 250 kilometers in diameter. So we could have a moon spiral in, and then as it gets in closer, then it can be destroyed in a tidal breakup when it gets within the Roche limit. Okay, so here is a possibility. We have, basically we have something that looks like this for a Triton, and Triton has an orbit that's decaying. It's getting smaller and smaller, and if it gets within this limit here of this yellow dotted line, then it will just get torn apart by the tidal forces that we have observed with regards to ocean tides around the Earth, or the tidal forces that we see that is causing Io to squish and to stretch. Okay, but when it gets within this Roche limit, then the whole thing just pulls apart, and that's a possibility for creating a ring of debris that we observed with Saturn. So overall, this is our creation story for rings. It can either come from two places: a moon getting torn apart because it gets within the Roche limit, or a moon gets impacted by something and a bunch of debris gets spilled out. Okay, so here's a little bit more about the Roche limit. And basically, if this force gets too large relative to the self-gravitational force of the moon, then the whole thing splits apart. When people get too close to a black hole, the same thing can occur, but we call it spaghettification, because as you might know, spaghetti is a long, thin noodle, and basically what we would see with a human is that your feet would, the distance between your feet and your head would increase, and be, your whole body would pull apart in that regard. Okay, so essentially we're all done with the Jovian planets now.